Hello friends, welcome to my channel. Today we will discuss about dependency inversion principle, which is the last principle in solid design. First, we'll discuss what is dependency inversion principle. Then we'll see the benefits of dependency inversion principle. We'll see the techniques we use to implement dependency inversion principle. Then we'll see the demo. Before that, if you are new to my channel, please do not forget to subscribe. Let's get started. What is dependency inversion principle? It is one of the 5 solid principles of object-oriented programming designed to improve the design and maintainability of software systems. What the principle states? The principle states that high-level models should not depend on low-level models. Both should depend on abstractions. Abstractions should not depend on details, but details should depend on abstraction. In simpler terms, the principle states that high-level module can be business logic, application-specific classes, and so on. High-level models should not directly depend on low-level models. What are low-level models? Low-level models can be specific implementations, framework, or external libraries. Both high-level and low-level models should depend on abstraction rather than concrete implementation. Abstraction can be interface or they can be used by abstract class. In traditional software design, high-level models most often directly depend on low-level models. This tight coupling creates a direct and rigid relationship between both high-level and low-level models. So, when we modify in the low-level module, it may directly impact the high-level module, leading to maintenance challenges and making system less flexible and extensible. Then, to address tight coupling issue, dependency inversion principle proposes the use of abstraction, typically in the form of interfaces or abstract classes. An abstraction is a contract that defines the behavior and service a module should provide without specifying the internal details of its implementation. So the core idea behind DIP is to invert the direction of the traditional dependency relationship between high-level and low-level models. Instead of high-level modules directly depend on low-level modules, both high-level and low-level modules should depend on abstractions. Let's discuss about the benefits of dependency inversion principle. By applying dependency inversion principle in your software design, you can achieve several benefits. First one is flexibility. Using abstraction allow you to change or replace the low-level implementation without affecting the high-level modules. This flexibility is essential for maintaining and evolving complex software systems. Next, extensibility. DIP makes it easier to add new feature and functionality to the system by introducing new implementation of the abstraction without modifying the existing high-level modules. Testability. With abstractions, you can create mock implementation for testing high-level modules in isolation, which promote easier unit testing. Separation of concerns. DIP promotes a clear separation of concerns between high-level and low-level modules, leading to a cleaner and more maintainable code base. Decoupling. By using interface or abstract classes, you decouple the different parts of the system that reduce the risk of cascading changes when modifications are made. Next, we'll discuss about the techniques for implementing DIP. There are various techniques to apply dependency inversion principle effectively. First one is dependency injection. Dependency injection is a technique where the dependency of class are injected rather than the class creating or managing the dependency. This can be achieved through constructor injection, property injections, or method injection. Next, inversion of control. These IOC containers are tools that manage the creation and resolutions of dependencies automatically. They can be automatically inject the appropriate implementations of abstraction into classes that require them. Next, factory patterns. You can use factory to create instance of classes based on the abstractions. It allows you to change the implementation at runtime. Let's illustrate the dependency inversion principle using a sample example. Consider a scenario where we have two classes. One is high-level module, another one is low-level module. And high-level module depends on low-level module. In this example, high-level module is directly creating an instance of low-level module, creating a tight coupling between two classes. Now let's refactor the code to apply dependency inversion principle using interface. I'll create one interface here. I'll name it as I low level module. I'll make this interface as public. Here I'll just declare the method that is void do something. Now low level module will implement this interface. I low level module. What this method is doing, it is just writing this text to console. Now we'll move to high level module, where we have, instead of low level module class, I'll just use the interface that is I low level module and apply the constructor injection to inject the low level module through interface. So what I'll do, I low level module and low level module. Low level module is equal to low level module. And here we are calling this low level method. In this refactored example, we have created a low level module interface to represent the contract of low level module. The low level module class implement the interface. Now, high level module takes the I low level module interface instance through constructor injection, which allow us to provide any implementation of I low level module interface when creating an instance of high level module. This way, the high level module is no longer directly dependent on the concrete low level module, and it adheres to dependency inversion principle. Now you can create the instance of high level module with different implementation of I low level module. It promotes a flexible and decoupled design. Overall, the dependency inversion principle is a powerful concept that encourages better software design and encourages loosely coupled and maintainable code. By introducing abstraction and inverting the dependency direction, you can make your software more flexible and ready to adapt the changing requirement. I'm done with dependency inversion principle. So that's all about solid principle. If you like my video, please do not forget to subscribe and hit the like button. Thank you.